Hey guys, this will be video 8 for the how to restore a vintage Gibson SG. And this guitar is a 1969. I've covered it extensively in the first 7 videos, so if you're just tripping up on this video series, check out those first videos to learn a lot about the SG. What I'm going to cover in this video is going to be primarily focused around doing your neck work, your lower, and getting it ready to continue to finish. And this is I would say this is one of the best ones I've ever done, but not being arrogant, it's just as good as all the others. So, if you do something long enough, you get really, really good at it. And I'm really happy. I've even learned like the little tricks of like what not to do. And I like to say, I think it's just as important to know what not to do in order to make certain that you don't make mistakes. But we're going to be talking about mother of pearl and how to set up to do your pearl inlay work and actually, turn it into an authentic, or at least a replica of the authentic guitar, even though this might have not been a particular type material. But we're going to talk about some of this stuff, and hopefully it'll be a really good video series. A really good video. Also, I think one of the most exciting things I'm going to talk about in this video is going to be in relation to like tones, tap tones, and this is going to be the headstock overlay that I'll be doing all the really beautiful multi-piece binding in order to actually pull off the fact that it is truly going to be, built per custom specs, as the listing title says. But one of the most important things that I ran across, and man, this is so unbelievably important if you've never worked with a particular historical guitar. I spent a lot of time talking about neck pitch to the body and the bridge height and all that stuff. And I'm not going to recap that in this video, other than how it relates to a certain location that's going on out here or here in relation to the flat plane of the guitar. If you get too much pitch, and let's just grab some numbers out of the air. Let's say typically like the 58 Explorer or the Flying V would have been around 1.5 to 2 degrees pitch. What that means is that's the neck to the body angle, looking at the body on a flat plane. Whether it has an arch top or not, that's irrelevant in this video. But the SG, or let's say like the Flying V and the Explorer, they typically have like a 1 3/4 to 2 degree neck to body pitch. So that would mean that you would cut, you would cut this angle right here. If you were using a miter saw, you would put it up on your miter saw and you would set this at 1 3/4 to 2 degree pitch, and you would make that cut. And then as long as this bottom of the tenon is flat and in the same plane with the top of the lower, which it should be. In other words, you wouldn't want to be doing any weird wonky pitching back here to try to fit into a body with a flat pocket. Because see, even the bottom of that pocket is machined 2.5 degrees. Well, this one is machined 2.5 degrees. But going straight to the finish line, this guitar, when I was doing some of my online research, I discovered that it varied anywhere from 2 degrees up to 3. And those were that information was from some really knowledgeable like luthier types that were commenting on the forums. And it led me to the realization that, well, yeah, that's probably true. It probably did vary from 2 to 3 degrees. And then I did trip up on a lot of information where it was obvious that it was someone that didn't know what they were talking about and making statements like it may be 5 degrees, it may be 7. If that's the case, then your bridge is going to be 1 3/4 of an inch off the body. So just always know that if you're building or restoring or working with a flat top guitar, make certain that you're working in the realm of about 2 degrees. Okay. This guitar, however, because it has the thickness, and this is a bit of a recap, but because it has the thickness of all the pickguard material up here that even goes behind the bridge, uh, this this bridge ends up being about 2 millimeter, roughly an eighth of an inch higher than your traditional flat top guitar. So, and spending about an hour in conversation with the client last night, we were really able to finalize, you know, am I going to come in here and install this neck directly in this body against the bottom that I've created, or am I going to shim it up, maybe 1/64th of an inch or something like that? And you'd be surprised how much that little bit of additional shim work makes a huge difference in clearances and playing feel and everything. And it was really cool because even the client would mention to me, he's like, well, for the most part, I really do kind of like a low profile playing guitar. Now, it's my job to not read into that, drop this thing down to the absolute bottom and make it absurdly low. You have to make certain that you listen to your client, but also realize that this guitar was designed to be a certain way at a certain height, et cetera, et cetera, et cetera. And that's what I mentioned in the first couple of few videos. If you go back and look and were to watch all those videos, you would see that the first one or two videos, I was in error. I really had no idea that this neck was actually a little bit higher out of the body than the Flying V and the Explorers and stuff like that. So that's why I came in when I was rebuilding this bottom. I made certain that I had these fillets in here that I could bring this baby up as high as I needed to, so that once all this got machined off, it created this really beautiful, historically accurate lower profile height. And when I talk about the lower profile height, I'm always talking about this plane right here. We'll deal with what goes on with the fretboard and the frets and string clearance later on. However, those dimensions are critically dependent upon getting this right here correct. And this is pretty important that I continue to just go off the cuff with this conversation, because what I'm trying to get at is, if you miss this, you're going to be living with a guitar that either you hate, can't get rid of, and I'm not being melodramatic because I've done it before. I've got a Penguin replica upstairs that I built about 15 or 20 years ago. Beautiful, beautiful guitar, but it's about a 16th of an inch too high. And every time I pick that guitar up, I always think, why in the hell did you not spend another 4 weeks if it took it to get that neck height right? So where I'm going with this guitar, the design has the pickguard right here, and you would think, okay, well that's cool. Then the bottom, the top of the fretboard, the bottom of the fretboards or the fretboard surface or the top of the lower could flush out like that right there, correct? Nope, it doesn't. It actually comes up almost 3/32 of an inch higher, and even before it ever gets the fretboard on it. I've already covered this in general in some of the past videos. Not quite that high, not that high at all. But all I'm saying is that's why all of this day after day after day of machine work and processing and engineering and thought process had to be done to make certain that I restored this vintage guitar accurate per those specs, but then still made it look like it was actually the original neck. And I really think it's going to be it's going to take someone like the George Gruins always say of the world, only because he's an aficionado and actually does really accurate appraisals, and all of the guys that are on his staff, they're able to look at a guitar like this and fairly quickly they can say, okay, well, yeah, it was a replaced neck, but man, how cool it is that whomever did the replacement took the time to make certain that they were the proper distance out of the body back here, and not just build it like it was an Explorer replica or something like that. Because had you have done that, this bridge would have ended up dropping considerably lower. Okay, so, and I spent a little bit more time talking about that than I wanted to, but I think it's a necessary recap because it's been about 5 or 6 days since I have discussed those things because I was focusing primarily on getting the initial build, the initial preparation for the body under control so that I could then stop worrying about, you know, where how where should I be cutting this distance right here? I'm sorry. You know, what should this number be right here? I actually could care less, believe it or not. I know the statement is I couldn't care less, but I couldn't care less what that dimension is. I just want to make certain that once it goes in and either epoxy glues in or animal hide glues in or resorcinol glues in or tight bond glues in, that once it's sitting in that pocket, making contact with all seven sides. One, two, three, four, five, six, seven. I want that end to just barely make kiss contact at the very end, but I do want to be able to pull I'm trying to reach over here and get a piece of paper. I do, once this is all clocking in together, I want to be able to drop a piece of paper down in there, especially for this one because we're going to be epoxying this neck in because the client and I, we've got such a great working relationship. We truly know Eric's a player. He's not a collector, a case collector, and he's not wanting to build this guitar in order to drop it so it's easy to get the neck out. We're going to build this baby like it's a touring performing guitar that is going to be acting like a through body design. But nonetheless, it's my job to make certain that I call it clocking, that I'm clocking I'll say all six sides, with this side right here having just a little bit of excess so that the epoxy that is in there can squeeze out. But once that epoxy dries, it then starts acting like a through body design. Okay, so I hope that makes sense. And if you do miss your target, you could do one of two things. You could come in here, and if you miss your target by extreme measures, I'm glad I'm thinking of this. Let's say you really miss the target by a mile. I wouldn't recommend coming in with that large shim because this thing might be a little bit off and you don't realize it. And now all of a sudden you created some sort of weird funky pitch change or roll change. I truly like the idea of, you should have already engineered it so that you would only be within like one shim, maybe two shims. So let's say I was going to do two shims here. On this job right here, I probably would use the tight bond, and then I would just tight bond glue this lower shim. And you guys know how to do clamps. I would just, put a block of wood on there, and then I would do just a nice firm clamp. 15 minutes later, I would come back with my X-Acto knife, trim the shim a little bit, and then put some more tight bond glue here and repeat the process. Let it dry for 15 or 20 minutes, and then trim the shim. Maybe let it dry for an hour before you start doing any additional work if you're working with the tight bond. But if you're going to be epoxying this in, let this dry for a minimum of about 4 to 6 hours, if not overnight. Okay, so what that did was that built up, that brought your neck back up to the proper height and all that jazz. And now, and so you're doing all this stuff after you've done all of this. Let me back up. You kind of should have done that before you did all this beautiful work up here, because now that I've got all of this, I'm very much within like 1/64th of an inch of the finished headstock. Well, not in the length, but definitely down here. That's the guitar. That's the headstock. So I gotta protect, especially that point right there. I can't even begin to drive home how important that is. Well, not necessarily on this guitar because it gets the binding, and I will be routing down into this just a little bit, but typically you're not. And I'm going to stop talking about that because I'll cover that in the latter part of the video. But you got to protect all these corners, and especially if this is your finished back, all these corners right here. And I recommend don't go ahead and try to do the final shaping yet. Leave it sharp, with a sharp edge. We can ease the edges later on, because if you do bump it, well, you can always just put a little bit of spit on it and saturate it, and it'll swell back up. So even if you had a real nasty little hit, I don't mean like with the saw blade, like if you got a nasty ding, then you wet it, and I mean like really, really wet it, and kind of keep it wet, and it'll swell back up. Then dry it, sand it, shape it, and you'll be surprised what you can get away with if you create a ding. Okay, so so I talked about fitting the neck enough to know once we, and I already had all that engineered, but I knew that there was a possibility that I was still going to raise this baby 1/64 of an inch. And oddly enough, even right now, I still don't know. But I did do my final engineering where I put this in based on the thickness of my fretboard, and I'm just going to say that this was right at exactly 6 millimeter. It wasn't. It was real close, but we'll say this was 6 millimeter. And then atop the 6 millimeter, you got the height of the fret once the fret goes in. And then obviously we know that once the string comes across the fret, well, it's not laying on the fret unless you're fretting that location. And what is that magic number? From the bottom of the fretboard to the bottom edge of the string, the D and the G, like E, A, D, and the G, I'm always working off the center because I know that's the highest point. The it wouldn't make any, well, just always work off the thickest point, because whatever goes on in the radius out here is going to be compensated for in the bridge. So if you're working off the center of the fretboard and you're working off the center of the bridge, which is the D and the G location, then your engineering is going to be within 1/64 of an inch after it's all said and done. And I just know that obviously having built enough guitars and having guitars upstairs or hanging over here on the side, I can just go over and measure and verify. Yep, it's still 2 millimeter to the bottom. In other words, it's still 2 millimeter clearance from the top of the fretboard, not the top of the fret, but from the top of the fretboard to the bottom edge of the string is 2 millimeter. So if your fretboard is 6 millimeter, add that to the 2 millimeter. Now we're working with the 8 millimeter dimension that rises up above. I'm having to be kind of rudimentary here. 10. Okay. So basically, we know beyond a shadow of a doubt that that's the bottom edge of the string, which is 8 millimeter. Okay. So I hope that makes sense. And what is 8 millimeter? It's 5/16. And that's why I was always talking about in the early videos, whatever you have at this location right here, just plan on adding 5/16 of an inch to that path, and then that will help you really hit this location on the money. And did we hit it on the money? Spot on. It's awesome. It's even going to have plenty of room. Let me get the table cleaned back up here a little bit. I like things to be kind of orderly when I'm doing the presentation, although when I'm doing the work, it's like most woodwork shops. It gets kind of chaotic, and there's tools everywhere, and there's dust everywhere, and it's kind of nasty. But if I'm doing a video presentation, I want to try to keep it as organized as possible. But what does it really boil down to? It's really comical. I always say that, well, typically when I'm building the guitar, I want to be able to, after this guitar is, man, this is like, I'm not going to say it. Okay. That's what I typically like to see after my guitar is built. I want to be able to slide a bamboo skewer under there and feel it drag as I'm pulling it out. That's a finished guitar if it doesn't have a pick guard. But we know this baby has a pick guard, and not only does it have a pick guard, but that pick guard goes around the bridge. And that's what I meant by, if you build the guitar per those specs, well, an SG, then you've missed your target. But I got to think, I thought, I wonder if they built this thing so that you could slide a bamboo skewer under here. Would that have been their There, and I'm trying to do these things where it's almost idiot proof, and you don't even have to measure. You're just shooting for like bamboo skewer clearances, and then you're good to go. But after I did that and pulled it apart, I say that to say this: that's pretty darn close, but that's a little bit too high. It's actually about a millimeter lower than that. So it ends. I went too much on that. So the reason I'm spending so much time with this is because when I saw that it was not similar or anywhere near the V or the Explorer replica, I knew that I had to really put my ego on the back burner, as I say, and verify that I didn't have to come in here and overcompensate with a steep pitch in order to get that high clearance back here. Because it took a long way. It took a long time to get here, but had I've come in here with a 3.5 degree pitch, now I would have created a whole series of very serious issues. Where let me just get a small. I think I can just do it with a quick grip. Let me build it up first. This is a little tricky because it has a. If you can see that, that's fine. If not, I'll show it to you in a second what I'm doing. Okay, I had to put a little eraser under there to hold it in. Okay, and what's exciting about that? I'll go ahead and dope a little bit, but straight to the finish line, man, I got a beautiful fitment already. I'll go ahead and cover this because I know what I was about to talk about. There's no way I could forget. So let's say I better not put the pencil on here yet because I'm still not certain. But what you would do at this point, see right now I'm catching, I'm basically I'm just about finished right there, but a little bit. But because this thing was shaped by hand, I'm going to be able to come in here with a pencil. That should be in the camera. And make a line right there, pull a line across the bottom. I'll have to get my clamp out of the way, pull a line across the bottom. In other words, follow the contour of the heel, which this one is about one of the wonkiest ones I've ever seen. It's really weird, so I'm gonna have to follow that. But then over here, you'll see that I'm hanging about a 30, I guess you will, if it's in the camera. Right there, I'm hanging about almost a 32nd of an inch wider. So that's where I'll be doing a pencil line right there. And then I will be shaping up to the point to where I ask myself, if they shaped this too much and screwed this guitar up, even from the factory, it's my job to make certain that I don't just blindly follow their mistake. And that would be where you would call the client and go, man, they missed this by, a 32nd of an inch. If I do that, it's going to screw up the fretboard and it's just going to be a weird guitar. So it would be better to feather it in down here where it looks really good. But then once you got up here to the top, that's what I was talking about. You flare a little bit. I'm not there yet, but I do know that this is the most narrow 19th fret location I've ever seen on any guitar. So I'm not there yet, and there's a possibility that the fretboard is actually going to be, I call it trickery. There's going to be some trickery going on with the binding and the shaping and the flaring. But once you look at the guitar up here, you even visually and physically, it'll be a perfectly straight line. So let me stop talking about that, but I just want to let you know that's where you're at now after you've done all of that. Sorry about that. After you've done all this shape work, you're now ready to fit the neck to the body because you're actually ready to glue the neck lower into the body after you get that right there shaped, if you want. This guitar will be having so much pearl work done that I'm going to do all of that pearl work and whatnot before I glue this into the body because I don't want to run the risk of, dripping, glue or something or some sort of chemical down on this body and I don't even know it, and it's got a screw up stripe on it. So I'll be doing all that work separate, and then one of the very last things that will happen is this net will get glued in this body. But from your engineering standpoint, let me get the Explorer. Where is it? I'll try to, let's see, no, I guess I'll just have to put this over the side because I have that Les Paul on the table for a very important reason. But at this point, you're just wanting to lay a straight edge. Let's see if that's even in the camera. Should be in the camera. You're just wanting to lay a straight edge across the top of the body and then assess the distance from the nut location. I would say the beginning of the fretboard. Measure up, because your headstocks may be different on a different guitar. All we're concerned about is the feel and the playing surface or the speaking length of the guitar. But I do want to know the relationship between this flat body and this beginning of the fretboard distance from the lower to there. I don't care what that number is right now. I'm just going to look at it and ask myself, okay, what does it look like? Looks like it's about close to 3/4 of an inch, somewhere in the 3/4 of an inch range. Now, and before you start trying to turn it into a Flying V or an Explorer, you simply do some air guitar. Put the strap button on, or if you can't do the strap button, just try at a minimum sit down in a chair. But you also want to feel the guitar on your person as you're standing there, and basically you just want to ask yourself, well, what does it feel like? Does it feel like the neck is up here like a Fender product where it's just straight in line with the body, or does it feel like a Gibson? And a Gibson, all the Gibson set necks are arched back. I mean, they're angled back a few degrees, 2 degrees up to 3, 4 degrees, something like that. And if it feels great, then awesome. You're ready to go. And that's what I meant by if it feels good, it looks good, and if it fits in the case. If you have the case, that's awesome, because if the case is designed to have a certain angle on the pad that is in the case, and then this comes up here, that shouldn't fall apart. I think I'll just slide back. And then if this comes back here and is sitting really beautifully in the because we know, that's basically about where it is. It's actually a little bit longer. But if the guitar is sitting in the case appropriately, then that's a very good sign that you hit your location. But if it's not, then back up and punt and ask yourself, well, is that an authentic Gibson case, or is that a remanufactured case that might be for a 70s Asian guitar that had a different pitch or something like that? Just makes, I'm not saying build your guitar around a case, but there's a lot of telltale signs by using things like that. Reference points is what I should be saying. There are things that you can use as reference points. Now, let me get the Explorer replica up here on the table. So we know that lower at the fretboard location drops roughly 3/4 of an inch from this plane right here. Okay, so what happens with an Explorer, which is what I can confidently call a replica? Looks to be about the same. And I'll shoot straight with you and tell you that I've already done this engineering, obviously, because if it were wrong, I would have been correcting it before I even did the video. But basically, you don't even really have to measure it. I'm sorry, I should be showing this right here. At the end of that straight edge Let's see if that's in the camera. I hope that's in the camera. Whatever that dimension is, is what you should be shooting for. And what is that dimension? It's roughly it's under 3/4 of an inch. It's about 7/8 to 15/16. So if I'm a Gibson player, and these things are so big, they're like an F-14 Tomcat coming off the end of an aircraft carrier or sitting on the aircraft carrier. But if I'm sitting here, and I'm playing an Explorer half the set, then I'm switching over to my SG for part of the set, and then I'm going over to my Les Paul or something like that. Then if I'm a Gibson player, I want them to feel like a Gibson. Or if I'm playing replica guitars that claim they are based on this product, I want it to feel like an authentic 1958. Okay, so it's a long-winded way of saying it's pretty easy. Where I'm going is just proceed with extreme caution with all the information online, because a lot of those people might not even have ill intentions, but they're just spitting out misinformation or something that they read or they heard from someone that was really trustworthy. And here's kind of I'll go. This is actually really important. Here's a myth that should be shattered. A lot of the guys we're talking about with the Explorer replica headstocks, like, well, they came in and they cut this headstock off on an angle and they put this board in here on all the way down to the bottom, and what that was for strength. And I was like, BS. What it was, Gibson was dealing with a certain thickness board that when they pitched that headstock 14 degrees, if they tried to come out of one board, the board had to be 3.5 inches thick for them to get their headstock out of. What Gibson was dealing with was a break point where their lower that they were making their necks out of was no longer thick enough to go any further. So they had a stop point back here that forced them to put a board in. And is there anything wrong with that? I'll say yes, because you built your headstock too strong. When you put that member in there on the cross grain against this, now when that guitar falls and it takes that blow, boom, boom, you did this real superior, super, NASA approved strengthening beam across here. And what does it do now? When it hits, the fracture locates the weakest point, the path of least resistance, which is going to be right in here, and now you broke your neck catastrophically. Whereas the way I build my guitars, I keep all the grains going this way, and my glue up lines is that everything goes together. It's fine, but if this guitar falls over and wham, takes a real catastrophic blow, I can just about bet you this guitar, it's going to break. It's going to break in line with the guitar, and this is going to act like a crumple zone. When it hits, it's going to break in a controlled fashion. And what is it going to save? It's going to save the neck, man. And it's going to make for a very, very easy re-epoxy repair. And within 16 to 18 hours, you're back on tour with that guitar. With that original design, that was, marketed as to be stronger and superior. Well, yeah, that's strong enough that you transfer all the fracturing into the neck or into breaking loose from the body. So just study a lot of your guitars that are damaged and ask yourself, well, why did it break down here? Well, was it a poor glue joint? That glue joint might have been fine with the tight bond if you had designed it so it would break free in a controlled fashion. Okay, so a lot of really good information there for you. And let me just set this down and get this straight edge off the table. And then probably what I'm going to do is pause and get the table organized, and then figure out how, as I say, get out of this video. Okay, I want to cover something here that Eric and I were talking about last night. I thought it was really cool, and I probably should have done this in the very beginning of the video, but let's just do a quick flyby of the Les Paul custom design headstock and what it looks like on the SG body. and I hope that was in the camera. It should be, but from a standpoint of complementary, and this is a great way to do it as well. If you're considering a certain headstock design or shape on a body that might be different, just actually go ahead and pull the headstock up against the body and ask yourself, are they exactly what I just said? Is it complementing what's going on with the body design? And I would say, uh, just as Eric said last night, he's like, man, there's just something about the always loved the Les Paul Custom, the larger headstock on the SG, but I never really cared for that larger headstock on the Les Paul. And and it was so, I think, and I apologize if you didn't say this, Eric, but I know we talked about it. I think you said, well, maybe it's because the SG body or something. He was like, it didn't make sense because the SG body being smaller, but it's not. And that's where I told him, I was like, you know what? It's funny. It's illusion because yes, it's thinner. It seems smaller, but when you look at the footprint of the SG, it's much larger right here than the Les Paul. And even though, see, this is a 59 template. Let me just set them on the table. And you might think, well, okay, well, see the Les Paul's bigger. It's bigger right here, and it's a little bit bigger right here, and it's longer, but not when you consider fret locations. See, that's the 16th fret location. See that right there? If you just compared them side by side, well, then you're comparing them at the end of the body to the 18th fret location. And I hope you can see that on my template. But there's an 18th fret location that I scored into this template. That didn't come from Stuart McDonald, but the end of the board, the end of the body is the 16th, there's the 17th, there's the 18th, and there's the 19th. Okay, so keep that in mind. That's the actual 19th fret location. But this one's at the 18th. So let's do this. Let's push this Les Paul the 59 template up to the 19th fret location. And now let's ask ourselves which one's bigger. The SG is longer by about a half of an inch. We're talking about in relation to the 19th fret location. And what does that mean? Well, that's how the guitar feels. That's how the guitar plays. The SG body is, and I'm spot on the 19th fret location. The SG body is a good 3/8 of an inch longer. It's bigger right here. Sure, the Les Paul goes up in this area, but look how much more wood you see and feel as the player of an SG right there in relation to the Les Paul. There's a lot more wood right here in this location and that location once you go to the 19th fret. So, with that said, the SG actually is kind of a bigger footprint. It's certainly a much bigger footprint right here. So therefore, it is far more complementary of a larger headstock. And when you start looking at things like this from like a industrial design standpoint, and you start considering compound radius, curvature, and stuff like that, there's a lot more compound work going on with the SG body. And see, this design came first, and it wouldn't surprise me if they were thinking along the lines of like industrial design artists, and they were asking ourselves, well, what can we do to make this come together and not only look really incredible, but be completely different, something no one's ever seen before, but also be functional. So therein enters the double cutaway. They had already been doing the double cutaway, but how appropriate that they put these two profiles together. And I'm like Eric, the custom profile is really beautiful. Headstock profile is really beautiful on the SG. And I know that's kind of funny seeing it, real short, but I'm just talking about design is design, and if design is complementary and beautiful together, you'll see it. Whether you just have a piece of paper, let me turn this over, and you just lay it up on the body, and you look at that and you go, oh, absolutely, those are beautiful together. That's really complementary. Any way you look at it, what would it look like if we turned it upside down, was wide at the bottom like the Paul Reed Smith? Kind of loses its flair. because that's really grandiose in like the whole open book, the crown, the version of the headstock end. So trust your paper. Your paper will not lie, and if it looks good on paper, it's going to look good in person. And then once you get it balanced, if you can get it balanced, then therein lies a really nice guitar. Okay, so let me get that off the table. So there you have it, Eric. The SG is actually a bigger footprint, and that's why it looks great with a bigger headstock. Okay, looks great with a small headstock too, so you can't go wrong. And checking the time, 40 minutes. Yeah, should be fine because I do want to talk about pearl work and binding, but at the very end of the video, because that's a completely different discussion topic, and I want to stay on point with design, footprint, pitch, because we obviously haven't glued the neck in yet. And before I forget, this is incredibly important that I covered this briefly. Why is that sacrificial member on there? Because anytime, regardless of the heel size, when you're working with an overhead or table, if this were on the tabletop and you had some sort of large jig that is allowed, okay, which would be, it would be turning this way. So you would be, if it's turning this way and you're cutting this side, well, then you're coming in and you've got your large jig that is holding you, clear on your perpendicular on your tabletop. Well, then you're coming in and you're machining. I hope that's in the camera. That should be perfectly in the camera. Then you're coming in and you're machining and run this at a slow speed. Don't run this at full speed as big as it is. You need to make certain that you get a variable speed control device for running your routers, because you got to slow these bits down to about, I think, 14,000 RPMs. But go in and then start putting, not one pass. You're going to be raising this bit because, and I didn't really want to talk about this, but now I got myself in trouble, because this is what you're starting with, right? You got this square surface and everything's S4S, so you're going to be going in and it's going to be pretty easy for this router bearing to actually follow wherever you start easing into it. And how many passes do I make? About 4. I do one pass here, second pass, third pass. Next thing I know, my bearing is getting right at the threshold of going beyond the center line. I'm gonna stop talking about that because that's another conversation for another video. But by having this sacrificial member on here, if you did not have it and you went up, you run the risk. I don't know anybody that's good enough to keep that under control. You're going to lose your heel, the router bit. If you're doing it overhead and you didn't have that part, let's see if I can do it over. Yeah. If you're on this side and your router bit is turning in this direction and you're coming off of that heel, then you run the risk, the great likelihood, if this were the bottom of the guitar and you didn't have the sacrificial member, then you're going to cut off the corner of your heel. So you have to have that sacrificial member in order to allow you to do that cut. And I've been wanting to break this off for like 2 days, but I couldn't because I knew I needed to show that in the video series. Okay. So I put masking tape on the bottom here, really made certain I actually cleaned it with lacquer thinner. Brushed it, cleaned the heel with lacquer thinner, and then put masking tape down on this side, and then masking tape on this side, and then I used a medium strength CA glue, pretty liberal, like quite a bit right here and quite a bit right there, almost too much. It actually crept over on the mahogany. That would get you in trouble if you weren't careful. Then I just glued those together, and it was just a square rectangular block. So now you're at a point to where because I'm going to start talking about the heel. This will be an awesome video because I'll be able to talk about the importance of how to machine a heel. Sorry. Let me pause. Okay, let's fit the neck in real time. And then, so I talked about the importance of using that sacrificial member, but also one thing I didn't get to clarify you can't machine this initial round directly to the finish line, which is I think it's 5/8 to 11/16 is typically what you want to see from that point there out to the end right there. So after it's all finished, you want that to be no more than like 3/4 of an inch. If you get beyond 3/4 of an inch, that's going to get fairly fat. But if you did your pre-radius work here all the way back to your finish line, the router bit is so big, and the way everything is, if it machines all the way down to that point, you'll end up completely cutting off. You'll lose the flat. You'll lose that flat. This line that you see right here coming across would end up being all the way back here. And if it was even worse, you'll end up cutting off some of that material right there, and that's game over. You lose your neck. So if you're good enough to shape this up here and blend all this work in where you did because obviously, you had to stop the router bit about this location right here, and every bit of this had to get shaved off by hand and shaped, which I don't have time to talk about that. But if you can pull that off, then you definitely can shape your heel. So always plan on shaping your actual heel by hand, and you leave whatever amount of flat in there that you want. If you want like the 80s, the 70s to the 80s profile, then you're going to want more of like the D, the flat D, and then go from there. See, that's a Les Paul, so it's a steeper pitch. This is the 2.5 degree pitch. But just study your subject, look at your flats, and ask yourself, what is it that you want to see after you build your guitar? And this is something I've never heard anybody speak of, but I'm certain that they're aware of it, like luthiers that have built a lot of necks. If you're replicating a neck for a client and you're fortunate enough to have the actual lower, you can then determine all this radius by actually just sticking a bit up there and saying, okay, is it 1 inch or is it 15/16 or is it 7/8? And the magic number is it's right at about a 1 inch radius, 2 inch diameter. But once you start getting your neck shaped, put the two of them together and just actually feel of it and turn it and ask yourself, do they feel the same? Your eye-to-hand coordination and all about feel. Even though this neck is both basically gone up here, I can still feel the all virtually identical profiles. So that lets me know that if I'm building a replacement neck for a guitar that is manufactured by a certain company, and I'm fortunate enough to have one of their necks from a certain era, then I'll be able to hit that era spot on. Or if the client prefers, no, I want the baseball neck, I want the fat, chunky, blah, 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 well, then you need to know how to convert over to a tighter radius and go with like a 7/8 inch initial radius. And then you start defining the finished guitar by, well, you've already engineered that stuff. But all I'm saying, make certain that you leave a lot of room because you're going to be coming in and having a template that you like to work with, and then you just start drawing, making marks, okay? And then now you're going to have to plan on how do you not go too far, okay? But I would rather work my way to the finish line with something like that right there from Woodcraft, which I talk about a lot. This is the little rasp that's flat on the bottom, radius on the back side. Obviously, I'll be doing the initial carving, with a chisel. And this is, I got this set up like what's it called, a katana sword, I believe. I shaved them over like that so they're razor sharp. And then you have to determine where's the grain, and you start easing off a little bit of material and then just start shaping it down. And one thing that's pretty important, actually, this is extremely important. If your body thickness right here is, we'll just say it's 1 3/8, but if that's 1 3/8 and this member up here is 1 1/2, well, then you're going to have an inaccurate carve because this radius is so steep if I were to machine off 1/16 of an inch, this dimension that is sitting here, right here, if I had to carve that and then shaved off 1/8 of an inch up here, well, now that heel's going to jump way out here a considerable amount. So with that said, I've actually got to go ahead and fit this to my body. I'll do this in real time because I'm fairly confident this is the guitar. My dad asked me once, he said, if you make the mark more than once, which line are you going to follow? I thought about it for a second, and I told him, I said, the darkest. and I'm actually being serious. Sometimes your mechanical pencil lead is wonky. It might be on a bit of an angle, and you'll get a false reading. So there's nothing wrong with either hitting the mechanical pencil across some 3000 grit sandpaper and making certain it's nice and square, because this is the finished guitar. The only thing that we'll be dealing with to make up differences from here on out will be the thicknesses of the lacquer that we're working with. Okay, so I got a strong feeling that is a 1969 SG. See if I can get that in the camera. Sorry, this is so hard to do sometimes. And then this light blinds it out and you can't see it hardly. Okay, so I don't know if you can see it, but I'm basically there. That's the guitar right there. I probably won't be taking much of that off at all, but I will be coming in a little bit right here. And what amount will I be taking off on the bottom? Not much. So I'm fairly close, but keep in mind the bottom of that SG is pitched. Okay, and this is why I was throwing a fit on the front end about why in the hell did they do that? Why didn't they just, see what I'm saying? Why didn't they just leave it straight? Why do they have to come in here and do this pitch? Because now you're having to carry that pitch up into the heel. Well, it's fine once you got the neck glued in here and this thing has not been stained yet, and you're coming across here with some sort of a board and you're shaping that off. But when you're refitting a new neck, you got to achieve that pitch but not get into this body. So it's again a humbling, very humbling restoration doing this type guitar, because it just is. Everything's done by hand. So I probably will pitch that just a little bit, or if anything, what I may do, I may actually anticipate the fact that it is going to widen, and I might cut my heel a little bit shorter back here. But I just want you to know, Eric, that's not your heel. You're not going to have this absurd, it's just not. I've already covered it. I don't need to go across that again. The heel will basically end somewhere in that area. And what will that look like? It'd be beautiful. It'll look like a 59 Les Paul. Well, it'll look like this right here, basically. Except your heel will be flush with the bottom of the guitar. Okay? And let's see what that looks like. Yeah, look at that. Look how close that is. So once you get, I'm going to turn. Sorry, I don't know if that's on the camera. But just, work your way to your finish line. And just know that magic number as it finishes out is about 11/16 max, 5/8 inch, but you have to start out wide in order to get there. So especially if you're doing all this machine work with the router. Okay, what else? Let me pause, get the table organized, and we'll go from there. Okay, let's dive back in and continue talking about the heel, because there's a lot more going on here than you would realize. And we'll talk about the mother of pearl and the binding and all that stuff in the next video. Okay, so you're getting ready to, finish your job because you want to, get it glued in. But at this point, you know that you got to take this material off. And if you come in here and just start carving and chiseling, you run the risk of screwing up. So I like the idea of taking advantage of your oscillating sander because obviously as this is turning, it's actually coming up out of the deck and then dropping down, and it keeps it cool. Oh no, completely forgot. When you have your oscillating sander, the most important tool in the entire shop, other than your safety glasses, is going to be this sanding belt cleaner. You can get this at like Harbor Freight. I think it's $10, but obviously you want to keep this nice and clean, and you can use this on your belt sanders as well. But now that you've got this funky thing that's no longer really square, and the only flat that you have in order to keep you true, not only do you have to keep it true on the table like this, but you have to raise this up so that once you come in and start machining this material off, you're not going in on some sort of weird angle and missing your target and possibly, screwing up the job. So the way you do that, just get a couple of boards, a couple of pieces of poplar that are nice and true and straight, and then just lean down at the edge of your table and sight down it and make certain that the center line of the neck, whatever it is here, is roughly the same down there. And I just know that after it's all said and done, it hits about right here. And I think I was probably the very first purchaser of the quick grip when they came out back in the 80s. Because that was the most awesome design I had ever seen, and it's really cool to see that they're still out there. But be careful with them, because like if you're using a quick grip like this right here, and you start clamping, they do have a tendency to pull. But if you're trying to clamp in line, you can roll it over like that, and it has less tendency to pull. So now we're wanting to go over to our routing station. Our sanding station. Let me just put that down so it doesn't get knocked off the table. Okay, so you're going to be going over to your router table, and this is turning in this direction, and you're just going to have a light shining in this direction. You're going to ease that little bit of material off. This is going to happen in about 15 seconds, and it will definitely be game over if you go beyond. Well, just know where the. Let me find it for you, and I'll just do a pencil line. Okay, the contour starts, or the rise starts right there. See, obviously this is a straight plane from this point to this point, but eventually it has to start radiusing, and it radiuses all the way out there. So the way I control that is I make some dashed lines, and that lets me know that is bar none, no man's zone. And then I come up here and just make some pencil marks, because all this is going to get sanded and shaped out. I hope my cap's not in the way. I apologize. I'm bad about getting my cap in the video. But just, make some marks. Nothing wrong with making some marks right there just to kind of get you started. So let me go over to the oscillating sander. And what is this magic number? This radius right here? It is a 3-inch diameter. Is that right? Yeah. I think it's a 3-inch diameter. Yeah, that's a 1 1/2 inch radius on your typical vintage guitars. Damn, there's so much stuff on the table. And how do you know that's accurate? Well, that's what Stuart McDonald says it is, and that's what I've seen on most of the guitars. And if you have the Stuart McDonald templates, you know that that's your location right there to sand to. But again, like I said, you couldn't sand it initially all the way up to that finished point, because once you came across with your router bit, you'd round off the corner. So let me pause, go do a little bit of sanding work, and I'll come back and we'll talk about what it takes to finish a hill. Okay, probably have about another minute or two before the camera cuts off, but it's kind of rough and it's kind of scary, because you're thinking, oh man, I lost the heel that I had, well, that's just all part of building a guitar, because I have not found a way to machine the heel and the headstock without having to get out the rasp. And quite frankly, this is really a really rewarding part of the job, where you start, you get it on a fixed jig, and you just start shaping, and keep your pencil marks up there, so you know what you're removing and what you're leaving. And I definitely always draw a pencil line here, because I want to leave as much flat in there as possible until the very end of the job, and then I'll determine how much of that flat I want to remove right there, kind of at the end, and even before I glue it in the body. So again, it'll be pretty much it'll be shaped identical to that right there, just about, and before it gets glued in, because I have no choice. I have a finished guitar. I can't be shaping and screwing up. I can't be shaping around that dark walnut. Okay, so I'll end the video right there. And I've got a lot of work to do. I left about an eighth of an inch in there just because it was for the video. Um, you should have never machined this right to the finish line to begin with. I've got about a 32nd of an inch. In the event you overshot your location, no big deal. Just come in with your large straight edge and just blend the two together, and you'll be fine. But if you overshoot it, substantially, you lost your job, or you'll be epoxying it and spraying over it with a dart. Okay, so I'll end the video there. I appreciate you guys dropping in. Hopefully it'll continue. Just do a little bit of initial fitment, and you see how it begins to come together. Okay, a lot of work. There's a lot of time involved, but after it's all said and done, 15, 20, 30 years later, it's cool to look over and pick it up and know that you took the time to do it right. So, can't believe it hasn't cut me off yet. Appreciate you guys dropping in, and we'll see you in the next video, and where we'll be talking about mother of pearl. All right, thanks guys.